Think back to when we did long division. Do y'all remember looking at questions like this, where we did the steps divide, multiply, subtract, bring down, repeat? And you guys complained the whole time because it was kind of hard, right? That's okay, because what if I told you there's a shorter way to do these kinds of problems? We're on our second day of division. This is called long division, but today you're going to learn about something called synthetic division. Now, synthetic division only works for a certain number of polynomials, specifically polynomials that have a divisor that is written like this, x minus k, meaning it is not squared, there is not a number in front of x, it is just a plain x plus or minus a number. If that's the divisor, or the thing that would go outside the house, then we can use what's called synthetic division. And really the point of dividing is to eventually factor, which we will do next class, or later today. And all the times when we factor, we're going to try to factor those kinds of binomials first. So this is a shortcut that we really, really want to get good at. So again, there cannot be a coefficient, so that's a number in front of the x, or an exponent on the x term. No squared, no cubed, no nothing. Just a plain x, no number in front of it, and then just number added or subtracted behind it. K can be positive or negative, and what we're going to call it is we're going to call it the house number. Okay, so similarly to long division, a number will go outside the little house, but synthetic division is different. Synthetic division is not set up the same way. You don't have the typical house that you had when you did elementary school division. Synthetic division, the house is flipped over. So you see this example here? You're going to put that house number, K, on the outside of an upside down division box or division house. To set up the rest of this, instead of putting the entire dividend, which is like the longer polynomial in there, you're only going to put the coefficients of the dividend. Coefficients means the number, meaning you ignore the letter and the variable. Those are the same things. You ignore the letter and the exponent. You just put the number that's in front of it. But the same rules apply when you were writing down a dividend. If you are missing any terms in the dividend, make sure you put a 0, and we will see examples of that later. The steps for synthetic division are written below, but it can be much simplified to the phrase Big Mama. If you write down Big Mama, but we're missing the IG in big, those are the steps for long division. So instead of divide, multiply, subtract, bring down, repeat, this is called Big Mama or Ba-Mama. Okay, the steps are down here. It says use the divisor to write the house number. That's what we talked about, the K being the opposite of the divisor number. You're going to write the coefficients of the dividend, making sure you put a 0. And then you follow the steps. Bring down. That sounds familiar. Multiply, add. Multiply, add, multiply, add, multiply, add, multiply, add, which means we're never having to divide or subtract in synthetic division. It is always multiplying and adding. Okay? Those are the steps. Not going to make sense till we see a few examples. Those examples are on the inside. So when you're ready, flip this over. Here's a nice clean example of synthetic division that we've done for you. So let's say we were trying to divide negative 9x to the 4th plus 10x cubed plus 7x squared minus 6. Notice that we're missing the 0x, and we even indicated that here. We're trying to divide that by x minus 1. What I want you to first maybe put a bigger box around is the fact that the house number is equal to 1. If the binomial right here says x minus 1, you always use the opposite term for k. So instead of minus 1, we're using plus 1, so a positive 1. That number goes here, my house number. Notice then that these numbers are all the coefficients from the dividend. Do you see how those are literally the same numbers? Oh, but there is a 0 because we were missing it. and then negative 6, negative 6. Do we see that? We just beep, 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 put all the coefficients down. The Big Mama steps say that we are going to bring down the negative 9. The multiplying and adding kind of looks like this. I'm always going to multiply by the house number, whatever number I just wrote down here. So what is negative 9 times 1? Boom, I put it right here, the next line in the L. Then I add straight down. 10 plus negative 9 is 1. Then I repeat. Always multiply the new number on the bottom times the house number. What is 1 times 1? 1, so I put that down. Add straight down. What is 7 plus 1? 8. Then we do 8 times 1, which is 8. 0 plus 8 is 8. 8 times 1 is 8. Negative 6 plus 8 is 2. So you see how it's going multiply, add, multiply, add, multiply, add the whole time? And again, we will do examples of this later. But for right now, we're just going to look at this one. When you finish, this is important. Everybody put a big star next to this stuff right here. The very last number that you add is your remainder. So we're going to put an R underneath that last number for remainder. The next number is your constant. So we put C for constant. That means there's no x term next to it. The next one has x to the first power, and then x squared, and then x cubed. You see how it's just getting bigger until we run out of terms? At that point, you just attach this coefficient to this variable, and you write it in your final answer. You attach this coefficient to this variable, let it be invisible because it's a 1, and write it in your final answer. You see what's happening here? The 8, that's the constant, is by itself, and then my remainder, just like in long division, goes on top of a fraction with the original divisor in the bottom, which is what we did last time. Again, not going to make sense when you're just looking at examples. We're going to do some examples. But this process is significantly easier than going back and doing a full long division problem. There's less chances of you making a mistake. I love synthetic division. It's very, very helpful when you're trying to do the stuff we'll do later this semester. Can we do one together? Great. Let's look at number 1. It says, use synthetic division to solve the following. Well, first things first, we need to make sure we know what the house number is. If I see that this says x minus 2 as the divisor, what's the house number I'm going to use? Positive 2. So I'm going to put a 2 right here. Then I'm going to draw like a giant L. I mean, I guess, is that a backwards L? No, that's a regular L. Then I need the coefficients of the bigger part. What's the coefficient of this term right here? What's the number in front of it? 1, so I put a 1. What's the number in front of the next term? But it's negative. You see how it said minus 10x? So this is negative 10. And what's the constant? What's the last term? 2. Okay, that's the setup. Do we have questions about the setup? House number on the outside, beep, 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 all the coefficients. Now we do Big Mama steps. Big Mama steps says the first thing we do is bring this down. Easy. Can we do Big Mama steps? The next thing we do is we multiply 1 times 2. What is 1 times 2? 2. We're going to write that number underneath the next term because the arrow took a spot, and then you go back up into the house after you multiply. 1 times 2 is 2. You put the 2 right there. I see you have a question. What is it? Where did I get the 1 from? That's the number I brought down. So the very first thing you do in Big Mama steps is bring down. That's the B for Big Mama. So we multiplied. We add straight down. What is 10 plus negative 10 plus 2? Negative 8. Fabulous. Then I multiply again. This time I'm multiplying 2 times negative 8. What is 2 times negative 8? Negative 16. Let me change my color scheme here because I think I'm going to confuse you if I keep changing my colors. Don't erase anything. I'm just changing my color scheme. Okay. We've multiplied one more time. What do we do straight down? Add. Negative 16 plus 2 is negative 14. Since there's no more numbers, I'm done. We just label. In the example I provided at the very top, what's the very first thing what do I label this part? The one on the very far right side. The remainder. So literally put an R underneath that. Because while we're learning, we're going to go ahead and put our letters there. What do I label the next one? Look down at the example. What did we label the next one? C. Who remembers what the C stands for? Constant. That's the number that's just chilling by itself. Then what do I label the next thing? Just regular x. If there is anything else, the next thing would be x squared. The next thing would be x cubed. The next one would be x to the fourth. So it just gets bigger. Great. All we have to do to finish this problem out is attach the coefficients in red and green to the variables if necessary. Meaning, the answer to this is 1x minus 8 plus negative 14 over x minus 2. Whoa. Where did all of that come from? Where'd the 1x come from? Because this very first thing says 1 should go with x. Now, I will tell you, your computers are going to count this wrong if you have the 1 showing, so we're going to let the 1 be invisible. I won't count it wrong on a quiz or something, but a computer will. It's not smart enough to know it's the same thing. The negative 8 came from the fact that minus 8 is your constant. Don't put a C next to it. That's just to remind you it's the constant, meaning it's by itself. The negative 14 is your remainder, so it went on top of a fraction. But where did this bottom part of the fraction come from? This right here, where did that come from? The divisor, this part right here. The second little term. Is that significantly easier than doing long division? I agree. So we're just going to practice straight up synthetic division today. This next problem, I will help you set up, but I want you to do the Big Mama steps. So in number 2, what number are we going to use for my house number? Negative 2, very good. So negative 2 goes on the very outside of the large synthetic division box, or L. I'm going to call it the L. What are the coefficients I put on the inside of it, though? 1, and then 4. You see, I'm just getting the coefficients from the dividend, which is the longer part. I'm going to leave you to do the Big Mama steps. Bring down, multiply, add, multiply, add, multiply, add till you can't do it anymore. See if you can write the final answer, the quotient. Okay, so the steps for Big Mama were bring down. Check. Did we all do that one? Sweet. Then we multiplied. Negative 2 times negative 1 is negative 2. Then we add. 4 plus negative 2, 2. Great. Then we multiply these two. Whatever you just wrote down, still by the house number always. So negative 2 times 2 is negative 4. Add straight down, I should get 2. Multiply again. Negative 2 times negative 2 is negative 4. Add straight down, I get 0. We always label R, C, X, and then let the power get bigger by 1 unit. So the final answer should look like this. And this is the version that a computer will accept, meaning the 1 is invisible. This is 1x squared plus 2x's plus 2. If your remainder is 0, that means you don't have the fraction at the end. If any of your numbers end up being 0, you don't have that letter. Let it be gone. What are your questions before we try, not a more difficult one necessarily, but one that has a few tricks? Do you see how to write it now, Kylan? Okay. You just attach the coefficient to the letter. Bless you. Okay? Now I want to tell you right now, number 3 has some tricks. Can anybody figure out what one of those tricks might be? Just by looking at it. There's only 2 numbers in the first thing, right? Which means we're missing a lot of terms. Which terms are we missing? Like, which powers of x's are we missing? Okay, well, I see 2x cubed, and then all of a sudden just a 54 with no x's next to it. So which powers of x am I missing? I'm missing x squared. What else am I missing? X. Am I missing anything else? No, because that would go x cubed, x squared, x to the first power, constant. Great. I needed you to recognize that because when we set up our L here for synthetic division, yes, the house number would still be -3, which is the opposite of the binomial. Make sure you got that part right. But in our house, we have to make sure that we have those zeros there as placeholders, just like we did for long division. So my house for this one should look like this. 2, oop, that's a highlighter. 2, 0, 0, -54. Okay, so if you are missing something in your dividend, put a 0 placeholder for it. Whether that's an x term or a constant, that has to be a 0. But then we do the Big Mama step. So y'all walk me through Big Mama. What do I do first? Bring down the 2. What next? Yes, multiply -3 times 2 and put it under the first zero. So -3 times 2 is -6. Add straight down. Still -6, great. What do I multiply now? -6 times -3, which is positive 18. Add straight down. Still 18. Repeat. -3 times 18 should be -54. Add straight down. These don't cancel because they're the same sign. We'd get -108. Okay. What do I label -108? What letter goes underneath it? What letter goes underneath 18? Under -6? Under 2. Great. I'm going to write the answer in this bigger blank space underneath here. The quotient, or how you would write this answer, would be 2x squared minus 6x plus 18 plus the fraction -108 over what? X plus 3. That's the dividend that I started with. That is so much easier than doing long division, right? I agree. Okay, before we do this remainder theorem, which is the bottom, I want to prove to you that this really is a shortcut for the types of problems that we did last class. So I'm going to go back to the one I showed you at the beginning of class. This last little part is called the remainder theorem. The remainder theorem is a part of factoring that's very, very helpful and will come back to us next class as well. The remainder theorem says that if a polynomial, f of x, is divided by x minus k, the remainder is r equal to f of k. Ugh, math words. In other words, the remainder, whatever we would get as the remainder if we were to do division, is just what you get when the function is evaluated at k, which is another fancy way to say plug in k. So if the polynomial is huge and the question just asks what's the remainder and you don't want to go through all the Big Mama steps, all you have to do is plug the house number in. And then beep, 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 put it in a calculator and you're good to go. Now we evaluated functions, I think last class too, maybe 2 or 3 classes ago, so this should look familiar. It says use synthetic division to evaluate at k. Now, if they tell you what k is equal to, don't use the opposite. We only use the opposite if it's in parentheses or it says x plus or minus k. If they just say k is -4, use -4. So if we're doing synthetic division for this, it would be -4 house box. This would be 5, -1, 13, and 29. Am I missing any terms that I need to be aware of in that dividend in f of x? Or does it go 3, 2, 1, nothing? 3, 2, 1, nothing. So we're good. We're not missing anything. Cool. Big Mama, we bring down, we multiply, we add, we multiply, we add. I know you have a calculator and can do the multiplying and adding, that's why I'm going a little fast. We multiply, we add. We label R, C, X, X squared. But remember, this question doesn't ask you to actually do the division. What is it asking you to do? It's asking you to evaluate at K, but the remainder theorem tells me that evaluating the function is literally just needing the remainder. So we write the final answer like this. We say f of -4, meaning I plugged in -4, is equal to that remainder. That's it. If you were to, in your calculator, take the number -4 and plug it in for every single x term in parentheses and press enter on your calculator, you would get the same answer, -359. Which means now you have two ways to evaluate a function, which is pretty cool. Plug the number in or synthetically divide it. The reason you would choose to do synthetic division over plugging the number in is if you have like a dumb calculator, which sounds rude to call it a dumb calculator. This TI-84 is a very smart calculator. Your phone, not so much. Plugging a number in on your phone is way harder, but synthetic division, when all you have to do is multiply and add, that's pretty easy to do with your phone, right? So depending on the resources you have will change how you want to do these problems, either just plugging it in or doing synthetic division. Okay, we're going to leave this last problem for you. I just want you from the beginning to end to see if you know how to set up, how to Big Mama, and how to write your final answer for the remainder theorem, which means I just want the remainder essentially. So go ahead and start this problem. I want to make sure you can set it up. There's a trick in this one, so don't go too fast. Always be aware to look for the tricks. I'll give you some time. Okay, quick check just to make sure we've got the setup right, because I see some of us are still working. The house number, because it says K equals, don't change. My house number should be 2. You only change it when it's in the parentheses or like x minus x plus. If it's just like equal, use that number. The setup should have looked like this. 5, 2, 0, -20, -6. Again, I know we kind of discussed this when I was walking around. Why is this 0 there? What's missing? X squared. Notice that we needed an x squared right there to have all of the powers of x. Always be looking for that little trick. Does anybody need more time to do the Big Mama steps? Okay. Big Mama says bring down, multiply, add, multiply, add, multiply, add, multiply, add. So the question here is to evaluate the function, aka what's the remainder? What is the remainder here? 50, because that last number is always your remainder. I always recommend also just going ahead and labeling everything, that way you get into that habit. Yeah, oh, that's a great question. Because we hadn't done one where we went to x to the third power. But we had x to the 1, x to the 2. That means this has to be x to the 3. If there were another number, it would be x to the 4. You just let that power get bigger every time. But to answer this one, because it's asking me to evaluate the function, we'd say f of 2 is equal to the number 50. Not too bad, huh? I really like synthetic division. 1, because it's very fast, and 2, because I'm not going to make mistakes with my powers, which is what was so hard about long division. was the letters and the powers. This leaves that out. It's just coefficients, just multiplying and adding. We can do that. This one. Now this is a polynomial that can be done with synthetic division because the binomial that I'm using at the back is still x minus or plus something. There's no squared, there's no nothing. So we actually, go ahead, Jamicia. We actually did some last class that you can't do synthetic division with, but most of the ones I'm going to ask you from here on out, you can use synthetic division. So just watching, don't write this down, I just want you to watch the process. The house number on this one, let me scoot it over, would be 3. My coefficients would be 1, 6, and 12. And Big Mama tells me to bring down, multiply, add, add. So my answer, oops, I can add correctly, 39. My answer, making this the remainder, this the constant, this the x, would be x plus 9 plus 39 over the divisor. Isn't that exactly what we got last class? Isn't that like 10 minutes less worth of work when you're doing it? I agree. You'll use a lot less paper. These problems go a lot faster. And it helps later on with the skill we need to do for factoring. So use this method. I would love for you guys to be amazing at synthetic division because it's so much easier. Does that make sense? Cool. Let's do the last little part of the notes.